Unfortunately, it was a scandal. It was a fraud. Those two papers published in the scientific journal Science, one in 2004, the other in 2005, were simply fraudulent. For many reasons, it was a sort of infamy because Professor Wang admitted paying a fee to a lab assistant, 1,400 US dollars, to get her egg. And it was also revealed by a report from an investigational committee at Seoul National University that the photos published in the article, those ones, are duplicates. So everything was fake. Everything was based on the fabricated data. And because when you have a clone, you presume that the cell derived from the clone are genetically compatible to the original tissue. Unfortunately, they simply attempted to get the HLA type of the derived cells, and they discovered that they were not the same, and the genetic profile was extremely different. So definitely this is not cloning. So after this episode, which was extremely recent, January, this has cast a sort of spell on embryonic stem cell research, and especially on human cloning. Now there are alternative solutions that are appearing, and it's, I think, interesting to have a look at them, especially umbilical cord blood stem cells, because they are proposing alternative solutions, and they propose a promising future for regenerative medicine, because many scientists are a little bit now full of despair after what happened in Korea, and they don't know if there is any real future after the fraud of Professor Wang. So let's get into this alternative solution. The therapeutic efficiency of cord blood stem cells were pioneered 20 years ago for a certain number of diseases. Those are the classic hematological diseases you can find, and for those diseases we found a really efficient outcome for cord blood transplants, for leukemias, lymphomas, for Fanconi disease, thalassemias, many other diseases, and actually here are the survival rates for unrelated donor cord blood transplant. Those are outstanding results. It is extremely positive to see such results. The most important column is probably this one. But if you look at it carefully, you can see that cord blood is now considered as efficient as bone marrow transplants. So the question is, should we replace bone marrow registry by cord blood banks? This is a question that is coming out more and more today, even if it remains a sort of taboo. We need to talk about the sort of competition between the two of them. I'll tell you a little more later why there is this competition coming out. We are experimenting, on a clinical basis, the efficiency of those cells for the past 19 years. Keep in mind that no clinical trial has been performed today on embryonic stem cells, nor adult stem cells. Very few on adult stem cells. There have been some experiments, but there is no comparison to what has been done for umbilical cord blood. 6,000 unrelated donor transplants have been performed throughout the world, and what is really important is to see that those transplants were mismatched transplants, and they were as efficient as matched transplant from bone marrow. This is something very important, because you know that when you're HLA typing someone to renew the bone marrow after leukemia, cancer, or something like that, you need to get a 6 out 6. You have 6 indicators, 6 receptors in the HLA tapping system. And what has been discovered is that when you get 5 out 6 or 4 out 6, the cord blood is still as efficient as bone marrow when it gets 6 on 6. So the efficiency is extremely, extremely promising for cord blood stem cells. Now, there are definitely some obstacles. Here are some of them. But, you know, the cell dose could be also expanded by some techniques. Ex vivo expansion, we can definitely increase the number of stem cells in a vial through biomaterials out of the human body. So you just get very few cells, and because they have this capacity of proliferating very fast, they can duplicate, and you can create a larger number of those cells to engraft them later on. So those techniques, even though those are obstacles, there are some rational hope to foresee a sort of improvement in the future. The first transplant, as I said, was performed 19 years ago. Now we are witnessing an expansion of private banking. There are more and more private banks coming out, developing all around the world, and I'll provide you some figures about this competition we are also watching between private banks and public banks. This is a very important data. Last year, cord blood transplant outnumbered bone marrow transplant in Japan. Now Japan is investing, the public banks, the Ministry of Health in Japan is investing more on cord blood banks than in bone marrow registries. Why? First, because of the efficiency for hematological disorders, lymphomas, leukemias, but because there is also great hopes for regenerative medicine, for other types of tissue than blood. And because of this plasticity, I'll show you that we can produce bones with cord blood. We can produce skeletal muscles with cord blood. Liver, neural cells, chondrocytes, cartilage, lung cells, cardiomyocyte, you can regenerate an infarcted heart with umbilical cord blood stem cells, renal cells, and also vessel cells. So the classic differentiation, when you go in a medical school, you can see this chart. This is a classical chart. You have here the progenitor cell. It is a stem cell in a way that it's not as immature as a stem cell. It's a later stage of development. However, you can get, after that, platelet, red cells, and lymphoid cells from this singular cell. Okay, this is blood. But what about other tissues than blood? Because blood is a liquid tissue, but you have solid tissues that were listed in the literature, scientific literature. And here is a sort of summary of what we can do. The pluripotency of those cells comes from those 3 germ layers. You know, the qualification of pluripotency is also debated today. However, everybody agrees that a pluripotent cell is a cell that can produce, you know, all the tissues derived from what we call the ectoderm, the mesoderm, and the endoderm. Those 3 germ layers are capable of producing the entire human body. Those cells have a great capacity of proliferation. In 100 days, this is the progression of those cells. They can duplicate very fast.